In Comp 2521, opaque data types are used for concrete implementations of abstract data types. This presentation goes over how they can be created. For the demonstration, we have a linked list ODT. In its header file, we have a typedef for our convenience, and we include function prototypes for operations to create, modify, and delete the linked list and its contents. Here, we would also include comments on the time complexity of each operation, which would be O of 1 time as is typical of a linked list ADT. We can also include preconditions and postconditions, like how the list size increases by 1 every time we append a number. Then we have the source file, which contains the implementation of the actual linked list. We have our structs and function definitions, and for the purposes of this demonstration, we can just assume everything in this file just works. The next step is to produce an object file, and this is going to be created from our list.c1. We can do this by calling gcc with the -c option and specifying an object file as the output. Note that as we are only compiling and not linking or assembling, we don't need a main function in our list.c file. Our main function instead goes in program.c. Inside of it, we create a list and then append 3 numbers to it. Then we print the size of the list, free it, and finally return from the program. Notice how we do not access the structs defined in list.c directly. We couldn't access them even if we wanted to, which is why our data type is opaque. Now we can link the list object file to our program. We simply pass the object file alongside program.c to gcc and use the -o option to specify the name of the executable produced. Note that the inclusion of the list object file implies the compiler can find the list header file in the same directory. However, the important part is that we do not need the list.c file at all. When we run the final program, it should just print 3. The main advantage of this approach is that it lets us modularize our code, which ensures maintainability. And if we are distributing proprietary libraries, we may not want to give the user our .c files. In this case, we can simply give them the obfuscated object files. However, the object files are compiler and architecture dependent. This means the user must use the same compiler version and computer architecture as us, which may not always be true.